We said that buffers exist in Node because JavaScript didn't have good ways to deal with binary data. Well, that's changing a bit in the next version of JavaScript in ES6, the latest version. So let's take a moment to talk about ES6 Typed Arrays. Now, we're not going to actually use these throughout the rest of the course, but it is good to know about them, just so that we're aware that the latest version of JavaScript, and therefore the latest version of the V8 embedded engine, has access to something that can deal with binary data. So here in my empty app.js file, I'll say var buffer equals, and then I'll create a new array buffer. And then I'll say a size. It wants a size in bytes. A byte is 8 bits. Number of bit is a binary digit, zeros and ones. So, in other words, a byte is 8 zeros or ones. Big word alert. A byte, 8 bits. Here's an example. 8 zeros and ones. That's a byte. So I'll say 8 bytes. So that's 8 times 8, or 64 zeros and ones. Make sense? So this is storing raw binary data. This is storing 8 bytes, that is 8 times 8, or 64 bits of data. And then this is not coming from Node. This is coming from the V8 JavaScript engine. This is a new feature in JavaScript. This has nothing to do with Node. It's just there because V8 is embedded in Node. Now, I can then deal with my data. How do I deal with my binary data? Well, I can create what's called a view, and a view is actually a typed array, meaning that it's an array, and I can deal with it as an array. I'll create an int32 array, and then give it the buffer to work with. What it really is, though, is it's simply a way for me to deal with the binary data in the buffer. If I change the array, I'm actually changing the buffer. When I read from the array, I'm actually reading from the buffer, and it will convert that binary data into whatever structure I say is the structure that I should be looking at. So in this case, I said int32. That means a number, an integer, stored with 32 bits, 32 zeros and ones. So how many numbers can I store in my buffer? Well, this is 8 bytes. That is, a byte is 8 bits. So this is 8 times 8, 64 bits. And this is 32 bits for one number. We'll use 32 zeros and ones to store one number, which means we can store pretty big numbers. But we can only store 2 numbers in this view. So I can use it as an array, and I can use regular base 10 numbers. And then I can console.log the view, and I can see the data in regular base 10, even though, see that, the 0 position holds a 5, the 1 position holds a 15, even though what's really happening is this is being converted into 32 bits for a 5 and 32 bits for a 15. And because the array buffer only holds 2 bytes, then all I can do is store that. So if I tried to put a third number in there, it doesn't error, but it's not there. The buffer doesn't have the storage for it. All right, makes sense? So this view is just letting me work with binary data in an easier way, letting me put in normal base 10 numbers. Now, we're not going to use this through the rest of the course because right now Node doesn't use this itself. It uses the buffer that's internal to Node on the C++ side. So we should be aware of it because we don't want to walk away thinking, oh, the buffer is there because JavaScript can't deal with binary data. It used to not be able to deal with binary data. This is new for ES6, so its availability depends again on what version of Node you're running. However, it's good to know about so that we have clear in our minds that the new version, ES6, the new version of JavaScript, does have ways of dealing with raw zeros and ones, with raw binary data. All right, let's move on.